Now, here's a paper straw. You can make a sound if you blow through it. If you cut it shorter and then blow through it, what will happen to the sound? A, B or C?
The sound will be louder.
The sound will change pitch.
The sound will stay the same.
Well, let's have a look at a film that might give you some clues.
On this board is a string which is fixed at one end and attached to some weights at the other. Listen to the sound the string makes when it's plucked. We can see that the string is vibrating to produce the sound. Now listen again after an extra weight is added. The string now produces a sound with a higher pitch. The weights pull the string so it becomes tighter and so vibrates faster when it's plucked. There are other ways of affecting the sound pitch of a string. These strings all have different lengths. The vibrating length of string is between the black strips of wood. The weight on each string is the same. The longer strings produce a lower pitch sound than the shorter strings.
So, does that help you answer the question? If you blow through the shorter straw, what will happen to the sound? Well, let's find out. Great, well, as you all saw in that demonstration done by Charlotte, the short straw produces a much higher pitch than the long straw. So answer B is right, and answers A and C are both wrong. Well, that's it for now. I hope you've enjoyed the challenge. Don't forget you can always wind the tape back and have another go at the questions you found difficult. Good luck. The next programme is about the Earth and beyond. Hello, and welcome to the Revise Wise Science Challenge. Today's challenge is about Earth and beyond. I'm going to show you 3 animations, and you have to find out which animation shows what the Earth does in space. Ready? A, this animation. B, this animation. C, this animation. Well, let's have a look at a film that might help you.
This shows the actual spin of the Earth. You'll remember that the Earth goes round the Sun, and it takes 1 year exactly to do that. But while it's doing that, it is also spinning on its axis. And that, of course, is a day and a night as it spins round.
So, does that help you to answer the question? Which animation shows what the Earth does in space? A, this one. B, this one. C, this one. Okay, well, as we saw in the video clip, the Earth orbits the Sun and the Earth rotates on its axis. So animation A is wrong as it only shows the Earth orbiting the Sun. Animation B is wrong as it only shows the Earth rotating on its axis. And animation C is right as it shows the Earth rotating on its axis and orbiting the Sun. Let's stop the Earth for a minute. What do you think is the time at point 1? Is it A, sunset, B, midnight, or C, midday? Well, let's have a look at a video which might give you some clues.
How do we go from day to night? It's nighttime in part of the world, but it's daytime in other parts. Britain faces the sun. It's daytime. But the other side of the world is in darkness. In Australia, it's the middle of the night. But the Earth rotates. As it rotates, parts of the Earth that were facing the sun turn away from it. The Earth rotates one complete turn every 24 hours, so day is followed by night, is followed by day.
So, do you have the answer? Well, the light side of the Earth is facing the sun, so it's daytime. And the dark side of the Earth is not facing the sun. There's nothing to light it up. It's nighttime. So, point 1 has just left the day and is entering the night. It's sunset. So answer A is right. A pupil decides to do an experiment. She stands at exactly the same spot at different times of the day. What will her shadow look like at midday? A, like this. B, like this. Or C, like this. Well, let's have a look at a film and see if that helps you to find the answer.
What I've got here is a little tower block.
Oh, yes.
And we'll see how the shadow changes during the day. And what I want you to do is to hold the torch at the 6 o'clock position.
Right.
And I'll draw the shadow on here. Like that. Well, I'll put a 6 on there so we remember.
Right.
And now, if you move it up to 10.
10, right.
Right. And I'll draw the shadow in again. Can you see how it's changed?
Oh, yes. It's a lot shorter.
That's right. Now, if you move it on to 12.
Midday.
Midday. And now, you see it's very short now. And now, if we go on to the afternoon, 4 o'clock, and I'll have to come round here.
Right.
There's the shadow. There, that's the 4 o'clock one. And let's do one more. 6 o'clock down there. And now we've got another long shadow over this side. Now that's the 6 o'clock shadow.
I see. That's amazing.
Now you can see that the length and direction of the shadows changes.
So, what will her shadow look like at midday? A, like this. B, like this. Or C, like this. Well, As we've seen on the film, the higher the sun in the sky, the shorter the shadow. So answer A is wrong. A shadow never shows the eyes and mouths of people. It only shows the outline. So answer C is wrong. So answer B is right. The shadow is short and doesn't show any features. Well, that's it for now. I hope you've enjoyed the challenge. Don't forget you can always wind the tape back and have another go at the questions you found difficult. Good luck.
You can get details of BBC Learning Zone's new schedule layout by going to our website at bbc.co.uk/learning zone. Well, programmes for schools tonight on BBC Learning Zone continue now with the history of medicine through time.
Welcome to History File Medicine Through Time. This unit, for the 14 to 16 age group, illustrates how factors such as religion, politics and war have affected the pace and nature of developments in medicine. It celebrates the achievements of key figures such as Harvey and Vesalius and helps students to enjoy a fuller understanding of societies from ancient Greece to the present day.
People of different religions disagree about what medicine can do and what it should be allowed to do. When should doctors be able to stop us dying? Should they be able to stop us being born?